Good morning, students. Today I am going to explain Vector Differentiation Unit 3, Part 2. In this Part 2, it consisting the three topics. Number 1, scalar potential, Laplacian operator, and vector identities. Now, scalar potential. After completion of this topic, student will be able to do problems on scalar potential. Now, before going to define the scalar potential, we have to know solenoidal vector and irrotational vector. A vector field F bar is said to be solenoidal if div F bar is equal to 0. If curl F bar is equal to 0, F bar is called irrotational. Now we have to define the solenoidal vector is div F bar, irrotational curl F bar. Both are equal to 0. Now we have to define the scalar potential. When F bar is irrotational, there always exists a scalar point function pi such that del pi is equal to F bar, then pi is called the scalar potential of F bar. And irrotational field is also called conservative field or potential field. Now we have to do some problems on scalar potential. Show that vector x square minus yz I bar plus y square minus zx j bar plus z square minus xy k bar is irrotational and hence find its scalar potential. In this problem, we have to do first part and second part. In the first part, we have to prove that F bar is irrotational. In the second part, we have to find the scalar potential function. Now let us coming to the first part, that we have to prove that F bar is irrotational, in which let us take the given F bar is equal to x square minus yz I bar plus y square minus zx j bar plus z square minus xy k bar. Now curl F bar is equal to del cross F bar. It is defined as in the form of determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3. Here f1 is equal to x square minus yz, f2 is equal to y square minus zx, f3 is equal to z square minus xy. And using the partial derivatives and determinant expansion, we have to express this one as I into minus x plus x minus j into minus y plus k into minus z plus z. Therefore, I into 0 plus j into 0 plus k into 0 is equal to 0 bar. Therefore, f is irrotational. Now, we can find the scalar potential for related to the given function f bar. Now, for that, we have to take f bar is equal to del pi. F bar is equal to x square minus yz I bar plus y square minus zx j bar plus z square minus xy k bar and del pi. Del pi is nothing but grad pi. Grad pi is equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. That means by taking these two terms on left hand side and right hand side, like term coefficients of on both sides, we have to equating. That is comparing the like term coefficients on both sides. That is the coefficients of I, coefficient of j, coefficient of k. Therefore, dou pi by dou x is equal to x square minus yz, dou pi by dou y is equal to y square minus zx, dou pi by dou z is equal to z square minus xy. And after that, we have to form the total differential equation, that is d pi is equal to dou pi by dou x into dx plus dou pi by dou y into dy, dou pi by dou z into dz. This is known as the total derivative, and we have to write the values of f1, f2. Dou pi by dou x is here taking as x square minus yz, dou pi dou y is equal to y square minus zx, dou pi by dou z is equal to z square minus xy. And integrating, we get integral d pi is equal to integral of plus integral of plus integral of, and we get the values of pi is equal to x cubed by 3 minus xyz plus y cubed by 3 minus xyz plus z cubed by 3 minus xyz plus c. Here we have to observe that three terms minus xyz, minus xyz, minus xyz are exists in the subsequent integrals. In this one, we have to take only one term and strike out the remaining two terms. Therefore, finally we get the required scalar potential pi is equal to x cubed by 3 plus y cubed by 3 plus z cubed by 3 minus xyz plus c, where c is the constant. And again we move to the next problem. Find the constants of a, b, c so that the vector a bar is equal to x plus 2y plus az I bar plus bx minus 3y minus zj bar plus 4x plus cy plus 2z k bar is irrotational, and also find pi such that a bar is equal to del pi. Here in the given a bar there are three unknown constants are there, a, b, c, that we have to find by using irrotational definition. What is the irrotational definition? Curl a bar is equal to 0. Therefore, del cross a bar is equal to 0 using the determinant expansion, determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z, and f1, f2, f3, and finding the partial derivatives and expressing the determinant, we can find the values of a, b, c. That is, a is equal to 4, b is equal to 2, c is equal to minus 1. And we can write the values of a, b, c in the given a. Wherefore, we have a bar is equal to x plus 2y plus 4zi plus 2x minus 3y minus zj plus 4x minus y minus 2zk bar. Here, a bar is irrotational, therefore a bar is equal to del pi. Therefore, you can easily find out its scalar potential. Therefore, I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z is equal to f1 I bar plus f2 j bar plus f3 k bar, equating the like term coefficients on both sides. Therefore, dou pi by dou x is equal to x plus 2y plus 4z, dou pi by dou y is equal to y plus dou pi by dou y is equal to 2y minus 2x minus 3y minus z, dou pi by dou z is equal to 4x minus y plus 2z. We have to find the total differential d pi is equal to dou pi by dou x, dou pi by dou y, dy, dou pi by dou z into dz. Therefore, we have to take the values dou pi by dou x, dou pi by dou y, dou pi by dou z. Therefore, d pi is equal to x plus 2y plus 4z into dx plus 2x minus 3y minus z dy plus 4x minus y plus 2z into dz. Integrating on both sides, we get the values pi is equal to x square by 2 plus 2xy plus 4xz plus 2xy minus 3y square by 2 minus yz plus 4xz minus zy plus 2z square by 2. Please see. Here, some terms are repeated in the subsequent. Here 4xz, 4xz, 2xy, 2xy. We have to take only one term, and therefore finally we get the solution, which is known as the scalar potential for the given function pi is equal to x square by 2 minus 3y square by 2 plus z square plus 2xz minus yz plus 4xz plus c, where c is the constant. And these are some problems that we have to do as a practice at your home. This is also very useful for examination purpose. These are the simple problems that you have to do and find the scalar potential. And then some of the quiz problems that are also very useful for online quiz examinations. These are models which are asked in the previous examination gate problems are also. Now again we move into the next topic, which is known as the Laplacian operator, that we have to explain in the next video. Thank you.